Hi, in this video we will be performing the analysis regarding fitting and validation of various linear and nonlinear allometric equations like linear, log linear, inverse, quadratic, cubic, compound, power, exponential. For that we'll be using a library which is available on CRAN, that is ImVol. So this is a library which is available in CRAN. So for that we'll be using a data set, that is VOL, and this is already imported, and this data set is by default present in this library. So for fitting allometric equations like linear, log linear, inverse, quadratic, cubic, compound, power, exponential, we don't need to write any kind of codes for that. We simply need to import or recall this library ImVol. Then what we have to do, we'll write something. Then we'll put the assignment operator or is equal to sign as usual. Then we have to use the default function here. Here we have to be cautious. It is L is capital here, but the name in the L in case of the name of library is small. Since R is case sensitive, that is why we have to be extra cautious about these things. So then we will click on this and we will put the name of the data, that is VOL. Then we will press enter and then simply write model. So after that you will see within one click what will happen. We have the results for fitting criteria, for fitting statistics, for cross validation including the half splitting, 70-30 ratio, 80-20, and we have some visualization also here. You can see for 50-50, for this 70-30 and 80-20 also, and you can see here we have the results for all the models. You can see we have the results for, say for example, in this scenario we have the output for 80-20, although we have the results for 50-50 also, for 70-30 also, but if we will see the results in context to the cross validation of 80-20, we have the models, we have selection criteria or selection matrices also here. We have root mean square, mean absolute error, Akai's information criteria, and more important, the prediction error rate across linear, logarithmic, inverse, quadratic, cubic, compound, power, exponential, linear. Well, the first 8 models they are utilizing only the information based on diameter, and here it is a combination of diameter and height for the prediction of this volume. But this is for training set, but we have results for testing set also in a similar way like we have for this training. Then what important thing is that we have a summary statistic regarding the fitting of these coefficients across the models for linear, for log linear, for everything you can find it out. So within one click you will get the outputs regarding the fitting of these allometric equations, which are very much used as far as the prediction of volume is concerned, as far as forest management works are concerned. So we can perform this kind of analysis in our software, the default R software. For that we simply have to just write this like this way. Again, this library is also available. You can find out the best models having a root mean square error lower is cubic, and it is HD5. The code of this model is HD5 and it has got a root mean square error of this. And again, this HD5 is in across the models is considered to be the best model. And in order to again see them one by one, for that we will write simply VOL, then click on this enter, and you will find we'll be having the results for across the cross validation techniques, and we have results for 50-50, we have results for this 70-30, and we have results for this one 80-20. So you can imagine how quickly these things can be done. And if you will zoom it out or extend it, you'll be having the results for compound HD6. It is coded as HD6. Then you can find out or select out which of the model is best or which of the model you want to choose, which of the equation, allometric equation you want to choose across these models, and in which cross validation procedure a particular model, a particular allometric equation is working fine with respect to the selection criteria. So this video will be beneficial for those people who are doing or who are performing the analysis regarding the fitting of linear and non-linear allometric equations. Hope this video will be beneficial, or you will find something new which can be done within a short span of time. Instead of writing those difficult codes, you simply have to recall this library, then import the data set, then write the default name of the library or default function, then within the brackets you have to simply put the name of the data, then press enter. So all the results will be done. Thank you very much.